Hello friends, welcome to Daring Marine YouTube channel. Today we will be discussing about writing moment and writing lever. So let's discuss about this topic, writing moment and writing lever. Mainly here discuss about stability topics. Okay, when a ship is inclined at an angle, center of gravity will remain same, but the center of buoyancy changes over to a new position, creating a moment called writing moment. When a ship is inclined at a particular angle, the center of gravity will remain same, but the center of buoyancy changes to a new position, creating a moment known as writing moment. So let us consider an instance. Let initial center of gravity of ship be G and center of buoyancy be V. So when inclined at an angle theta, center of gravity remains same, but the center of buoyancy changes to B1, like I mentioned. Here it is there. So center of buoyancy changes to B1. Center of gravity remains G. Okay. Here angle theta, angle of heel. So therefore this downward force due to center of gravity and upward force due to center of buoyancy create a momentum. That means it's known as writing momentum. So downward force due to center of gravity and upward force due to buoyancy, they will create a moment known as writing momentum. That is delta G into Gz. Delta is equal to mass of ship. Delta G means weight of ship due to gravity. The same force acting upward as buoyancy force. Therefore momentum is equal to delta G into Gz. The vertical separation between weight and buoyancy force is known as writing lever, which varies with the angle of heel. The vertical separation between weight and buoyancy force is known as writing lever, which varies with the angle of heel. Okay, that downward force due to center of gravity and upward force due to buoyancy, that will create a momentum, that is known as writing momentum, delta G into Gz. Delta is equal to mass of ship, weight of ship is equal to delta G. So that means same force acting upward as buoyancy force. Therefore momentum is equal to delta G into Gz. Vertical separation between weight and buoyancy force is known as writing lever, which will varies with the angle of heel. Stiff and tender ship. The other two types of ship, stiff ship and tender ship. Those ships with a large metacentric height having a large writing momentum at a small angle of heel and which is difficult to incline, so that which will return to its original position so quickly around a stiff ship. Stiff ship are ship with large metacentric height. They have a large writing momentum at small angle of heel, which is difficult to incline. They will return to its original shape so quickly. They are known as stiff ship. This type of ship there does not offer comfortable rate for a time period to return to its original position. It is very small. This type of ship there does not offer comfortable rate for time period to return to its original position is very small. Stiff ship means these ships have large metacentric height. They have a large writing momentum at a small angle of heel. It is difficult to incline, so that they will return to its original position very quickly. So that's are called stiff ship. This type of ship that does not offer a comfortable rate for time period it to its original position very small, so that this type of stiff ship does not provide comfortable rate. Tender ship, when ship's metacentric height is small, writing lever and writing momentum at small angle of heel become small. Such type of ship are easier to incline and will not tend to return to its original position so quickly. These are known as tender ship. Tender ship are kind of ship means ship's metacentric height is small, writing lever and writing moment at small angle of heel that also becomes small. Such types of ship are easier to incline and will not tend to return to original position so quickly. This type offers comfortable rate as well as easy rolling for time period to return to its original position being high. This tender ship, this type of ship offer comfortable rate as well as easy rolling for time period to return to its original position being high. So we usually neither two ship nor two tender ship are preferred. Instead, but that intermediate condition is preferred because that's best. If stiff ship does not provide, they have enough stability but not provide safe riding, it will be the riding will be very bad. So we prefer neither no too stiff or nor too tender. We prefer intermediate condition is preferred. When a ship is said to be in equilibrium, stable, unstable and neutral equilibrium. Okay. When we say a ship is said to be in equilibrium, and types of equilibrium, that means stable equilibrium, unstable equilibrium and neutral equilibrium. Okay. Equilibrium means when a ship is in upright position, the force of buoyancy, that means upthrust, and force of gravity that act downward through center of buoyancy and center of gravity respectively in the same vertical line, then ship is said to be in equilibrium. Equilibrium means when the ship is in upright position, that means the force of buoyancy and force of gravity act through center of buoyancy and center of gravity in a same vertical line, then ship is said to be in equilibrium. Here the picture we can say same vertical line, force of buoyancy act upward and force of gravity act downward. Stable. Stable equilibrium means when the ship's metacenter M lays above the center of gravity, then vessel is stable. That means GM is positive. Here force of buoyancy act upward through metacenter and force of gravity act through center of gravity, thereby creating momentum which tends to right the ship. Stable means when the ship's metacenter M lays above center of gravity, then vessel is stable. GM is positive. Here the force of buoyancy act upward through metacenter and force of gravity acts through center of gravity, thereby creating momentum which tends to right the ship. Okay. Then unstable equilibrium means when the ship's metacenter lays below the center of gravity, the momentum acts in opposite direction, increasing the angle of heel. Hence, the vessel will not return to its upright position. Then vessel will be unstable. The GM is negative. Unstable equilibrium means when the ship's metacenter lays below center of gravity, the moment acts in opposite direction, increasing the angle of heel. Hence, the vessel will not return to its upright position. Then vessel is said to be unstable. That means GM is negative. Unstable equilibrium. The neutral equilibrium means when the ship's metacenter and center of gravity coincide at same point, then vessel is said to be neutral equilibrium. There is no moment acting on ship, so it will remain inclined. Neutral equilibrium means when the ship's metacenter and center of gravity coincide at same point, then vessel is said to be neutral equilibrium. Okay, there is no moment acting on the ship, so it's remain inclined. Neutral equilibrium. Okay. These are the types of equilibrium. Inclining experiment, their theory and explanation. Inclination experiment on ship. So let's discuss. Inclining experiment or inclination experiment is conducted by shipyard to determine the metacentric height and hence height of center of gravity of ship. So this inclination experiment is usually done on dry dock on shipyard to determine the metacentric height and hence the height of center of gravity. If the height of center of gravity of an empty ship is known, it is possible to calculate position for any given condition of loading. So if we know the center of gravity of an empty ship, that is easy or it is possible to calculate the position for any given condition of loading. This experiment is conducted on an empty ship with minimum personnel to conduct the experiment. A small mass M is moved across the ship through distance d. This causes center of gravity to move from its original position g to center of g1. So delta is equal to displacement of ship. G1 is equal to m into d by delta. So means inclination experiment is conducted by shipyard or in dry dock to determine the metacentric height and hence the height of center of gravity. If the height of center of gravity of an empty ship is known, it is possible to calculate its position for any given conditions of loading. This experiment is conducted on an empty ship with minimum personnel to conduct experiment. A small mass M is moved across the ship through distance d. This causes center of gravity to move from its original position d to center line g1. So delta equal to displacement of ship. G1 is equal to m into d by delta. Okay, here's a picture. So when the center of gravity, center of buoyancy changes from b to b1, the ship heels at an angle theta. Okay, when center of buoyancy changes from b to b1, there will be ship's angle will change from angle of heel will be theta. From the above diagram, G1 is equal to gm tan theta. So gm tan theta is equal to m into d by delta from equation 1 and 2. So gm is equal to m into d by delta tan theta. In the above equation, only known value is theta. To determine angle of heel theta, suspend a pendulum. The deflection of pendulum may be measured when the mass is moved across the deck. If L is equal to length of pendulum, tan theta is equal to A by L. Gm is equal to m into d into L by delta into A. Height of transverse metacenter above the keel may be found out from the metacentric diagram and hence height of center of gravity of ship may be determined. Kg equal to Km minus Gm. Height of transverse metacenter above the keel may be found from the metacentric diagram and hence the height of center of gravity of ship may be determined. Kg equal to Km minus Gm. How to conduct inclination experiment on board? How we can conduct inclination experiment on ship? Stabilograph, it is a tool that is used to conduct the inclination experiment. Stabilograph, it is an instrument that is used to conduct the inclination experiment. Stabilograph, it is a special tool consisting of heavy metal pendulum balanced on a knife edge and connected to a pointer to record the heel angle reading. Stabilograph is a special tool consisting of heavy metal pendulum balanced on a knife edge to connect a pointer to record heel angle reading. Conditions need to be satisfied. The experiment must be carried out very carefully to have the accurate result. It must be calm with no wind, no disturbance from wave. Sufficient water should be under ship. All pipes, boiler, expansion tank are to be filled according to normal sailing condition. All pipes, boiler, expansion tanks are to be filled according to normal sailing condition. At least 2 pendulums are used, one forward and one aft. There should be 2 pendulums, one forward and one aft. They are made as long as possible and are suspended from some convenient point, example underside of the hatch. At least two pendulum are used, one forward and one aft. They are made as long as possible and are suspended from some convenient point, that is underside of hatch. Condition it will follow means, by conducting English experiment means, experiment must be carried out very carefully to ensure accurate result. It must be calm with no wind, no disturbance from the wave. Sufficient water should be under the ship. All pipes, boiler, expansion tank are to be filled according to normal sailing condition. At least two pendulum are used. That means one forward and one aft. They are made as long as possible and are suspended from some convenient point, example the underside of the hatch. So a stool is arranged in a way of each pendulum on which reflections are recorded. Pendulum poops are immersed in water or light oil to dampen the swing. Okay, the stool is arranged in a way that each pendulum on the reflections are recorded. The pendulum poops are immersed in water or light oil to dampen the swing. The procedure means, here just before we say about the condition that need to be fulfilled, now procedure for taking the international experiment. Conducting the international experiment. 4 masses A, B, C, D are placed on the deck. That means 2 on each side of the ship near the midship, and their centers are as far as possible from the center line. That means 4 masses A, B, C, D are placed on the deck, 2 on each side of the ship near midship. Other centers being far as possible from the center line. Mooring ropes are slackened and the ship to shore gangway removed. The draft and density of the water are read as accurately as possible. The draft and density of water are read as accurately as possible. Inclining masses are then moved one at a time across the ship until all 4 are on one side, then all 4 are on the other side, finally 2 on each side. So means the inclining masses are then moved one at a time across the ship until all 4 are on one side and then remaining 4 on the other side, finally 2 on each side. The deflections of the pendulum are recorded on each moment of masses. We will record the deflection. An average of this deflection is used to determine metacentric height. The average of this deflection will find out metacentric height. An experiment should be carried out. We have to ensure that this experiment should be carried out in calm weather. This is how we do doing inclination experiment. Then what is free surface effect? Free surface effect and how to reduce the free surface effect on ship. Free surface effect means when a compartment is not completely filled with liquid, it is said to have a free surface that tends to remain horizontal. As ship inclines, liquid flows to lower side in the direction of inclination, thereby increasing the inclining moment. Free surface effect means when a compartment is not completely filled with liquid, it is said to have free surface that tend to remain horizontal. As ship inclines, the liquid flows to lower side in the direction of inclination, thereby increasing inclining moment. Consider a compartment or tank containing a solid weight. When the ship is inclined, the center of gravity remains same. Only the center of buoyancy shifts towards the direction of inclination, and the rating arms are found. So, consider a compartment or a tank containing a solid weight. When the ship is inclined, the center of gravity remains same. Only the center of buoyancy shifts towards the direction of inclination, and rating arms are found. Okay. Here is picture. Okay. Now replace the solid weight with a liquid of the same weight. Now in this scenario, if we change the solid weight and replace the liquid weight, the ship is inclined, the surface remains horizontal, but liquid flows to the lower side, which is equal to the transfer of weight to the lower region, thereby causing change in center of gravity, thereby reducing metacentric height, reducing rating lever and increasing angle of heel. So if we replace solid weight by the liquid of the same weight, then when the ship is inclined, surface remain horizontal, but the liquid flows to the lower side, which is equal to the transfer of the weight to lower region, thereby causing change in center of gravity, reducing metacentric height, reducing rating lever and increasing angle of heel. How to reduce free surface effect? Pocketing. Free surface effect can be decreased to a certain magnitude by inducing pocketing. Free surface effect can be decreased to a certain magnitude by inducing pocketing. Pocketing happens when surface of liquid comes in contact with top or bottom of tank, thereby reducing breadth of the free surface effect. This pocketing happens when surface of liquid comes in contact with top or bottom of tank, thereby reducing breadth of the free surface effect. Surface permeability. The objects such as engine and pumps, machinery, piping system, etc. are prevent the moving of water and shifting of the wedge, thus reducing free surface effect by reducing the flooding water that can fill the space. Surface permeability means objects such as engine, pumps, machinery, piping system, etc. are to prevent the moving water and shifting of the wedge, thus reducing the free surface effect by reducing the flooding water that can fill the space. Swash bulkheads or baffle plate. These are vertical bulkhead for resisting the flow of oil or water due to rolling or pitching, thus reducing the free surface effect. Swash bulkheads are found in voids, double bottom, tank bilges, etc. Swash bulkheads or baffle plates. These are vertical bulkhead for restricting flow of oil or water due to rolling or pitching. This reduces free surface effect. Swash bulkheads are found in voids, double bottom, tank bilges, etc. Sluice valve. The free flow sluice valves on tanker allow opposing tank to be cross connected. The sluice valves, these are usually on tankers that allow opposing tank to be cross connected. When large partially filled tanks are connected, free surface effect increases when the vessel becomes less stable. Angle of list. Let's discuss about angle of list. Angle of list, it is the degree to which vessel heels to either port or starboard at equilibrium with no external force acting upon it. Angle of list is the degree to which vessel heels to either port or starboard at equilibrium with no external force acting on it. Listing is caused by uneven load distribution. Listing is mainly caused by uneven load distribution of weight abroad due to uneven loading, or to flooding either part of central line. Listing is caused by uneven load distribution of weight abroad due to uneven loading or to flooding either part of central line. If a listing ship goes beyond the point where a rating moment will keep it afloat and it will capsize and potentially sink. So if a listing ship goes beyond the point where rating moment, it will keep it afloat, it will capsize and potentially sink. Okay. Angle of list is the degree to which a vessel heels to either port or starboard side at equilibrium with no external force acting on it. Listing is caused by uneven load distribution of weight abroad due to uneven loading or to flooding either part of central line. If a listing ship goes beyond the point where a rating moment, it will keep it afloat and it will capsize and potentially sink. What is meant by angle of load and their corrective action? Angle of load and their corrective action. When a vessel has negative metacentric height, we can say it is in unstable equilibrium. Any external force applied to this vessel will cause to start heeling. Then gradually it will capsize. When a vessel has a negative metacentric height, usually it is unstable equilibrium. Any external force applied to the vessel will cause it to start heeling. As it heels, moment of inertia of vessel, that means water plane, that may plane intersecting hull of water surface, this will which will increase the vessel's metacentric height, that means distance from center of buoyancy to metacenter. As the vessel heels, moment of inertia of vessel's water plane increases with increase of vessel's center of buoyancy to metacenter. Since there is relatively little change in keel to center of buoyancy, then distance from keel to metacenter of the vessel also increases. So due to this small angle of heel, there will be little change in the distance from keel to center of buoyancy. The distance from keel to metacenter also increases. So at some angle of heel, say if it is a 10 degree, km from keel to metacentric height of ship will increase sufficiently equal to keel to center of gravity, thus making metacentric height of the vessel equal to 0. When this occurs, vessel goes to neutral equilibrium, and the angle of heel at which this happens is known as angle of load. At some angle of heel, say 10 degree, this km from keel to metacenter will increase sufficiently equal to keel to center of gravity, so thus making metacenter height of the vessel equal to 0. When this occurs, vessel goes to neutral equilibrium, and the angle of heel at which this happens is known as angle of load. Normal at the angle of load, the vessel oscillates about its angle and returns to their angle of load position. Normally during angle of load, they will return to its original position. However, even though this vessel appears to be stable, but if it didn't correct this condition very properly, it is very become dangerous, and finally the ship will capsize. So normally at the angle of heel of vessel, they will oscillate and they will return to the normal angle of load position. But even though the vessel appears stable at this condition, it is dangerous and must be corrected, because an unstable ship with angle of load, it could capsize. So corrective action means angle of load can be corrected by lowering center of gravity, not by moving load transversely. By not moving the load transversely, we need to reduce the center of gravity, lower the center of gravity. Press up slack tanks and lower weight as possible. We have to press up slack tanks and lower the weight as possible. If ship is discharging cargo, discharge from the high side, which helps to lower the vessel center of gravity. Okay. If the ship is discharging cargo, discharge from the high side, which helps to lower the vessel center of gravity. These are the corrective action. Then run up self water in the ballast tank water on the low side. We have to run up water on the ballast water tank on the low side. After the tank is full, run up its counterpart on high side. Repeat this action with other tanks until the ship become unstable. So we have to repeat this full action until the counterpart also on the high side, and repeat this action with other tanks until the ship becomes stable. These are the corrective actions that we can do during angle of lull. Thank you.